This is Albert Nardi from Barcelona Science. In this video, we are going to show how to solve in GibbsStudio one of the classical examples of geochemical modeling, the analysis of calcite dissolution under different CO2 pressures. This example can be found in the Apple on Postma book and is available at the Tony Appelos website. This is the Tony Appelos website. We're interested in the calcite dissolution example. Here it is. This model represents how calcite dissolves under different CO2 pressures. It is a nice example to start feeling the nonlinearity of geochemistry. As we see, the conservative mix of two different waters already equilibrated with CO2 and calcite leads to a water which is far from calcite equilibrium. If we take a look at the Phreeqc input, we find four different simulations. First, one initial fresh solution equilibrated with calcite that we make react with different amounts of CO2 dissolved. Second, the speciation of a water in equilibrium with calcite and with a CO2 pressure of 1.7 atmospheres. Third, the speciation of a water in equilibrium with calcite and with a CO2 pressure of 3.5 atmospheres. Fourth, the mix of the two previous solutions. Okay, now it is time to open GibbsStudio. We will create a new project from scratch. We will start importing the model that we are going to use by copying and pasting it. There are a few keywords that are not allowed in GibbsStudio. One of them is user graph. We can remove these forbidden keywords by pushing this button. Now, our model is free of user graph sections. This model uses the default database. The default database is the bold one of the list. In this case, Phreeqc.dat database. In case you want to use a different one, you need to create a new database item and point it from the model later. Regarding the selected output, we have also the default item selected. In the selected output item, we have selected only some output basics. We need to add our desired outputs, total calcium and CO2 saturation indices. Great! We are ready to solve our model. This study points to our just modified model. Here, we enable the Phreeqc output we are interested in. By pushing the play button, we solve the model. And we can find the results in this right section. You find the requested Phreeqc outputs on one tab and the selected output shown in the table format on the other tab. Now we are going to filter these results in order to be able to plot them later into different series. We first filter the calcite curve evolution. This data corresponds to simulation 1 and the part of the simulation of react. We should point to the source data view. We rename the item. And here we have our filtered data. We're not interested in the cell number raw value. And here we have our first filter chain. Now we filter the 2, 3, 4 simulations. At this point, we're ready to create the plot. We assign the data source we are interested to use We add now a scalar trace for calcite dissolution, and the mathematical expressions we're interested to use in X and Y. Notice that it's very easy converting Phreeqc output values to our desired output units by using mathematical expressions. Now we're ready to create the plot. We add some layout adjustments. Now, we will duplicate the trace and change the data source to draw the mixing conservative line. As we can see, data provided by our Phreeqc model is not ordered nicely for plotting. You can order your rows by ascending value of a certain column, pH in this case, using the following statement. And here we have our expected results. We hope you enjoy it. Thanks for your attention.